Yeah, welcome back students. In this class, we are going to derive the first electrical characteristics of MOSFET, that is IDS versus VDS characteristics. Okay, to derive this electrical characteristics, I have considered an NMOS transistor. Now you can observe that I have considered the length of my channel as L, the width of my channel as W, and the thickness of the channel as D. And it consists of three terminals: gate, source, drain. But don't forget one more terminal it consists of. What is the fourth terminal? That is what? Absolutely, bulk. That means body you can consider. Here I would like to discuss one very important point here. Okay, whenever there is a potential between gate and source, okay, if you observe that if you connect a battery between gate and source, then here you are having a polysilicon. Is it clear? Then here you are having a polysilicon, then the positive charge carriers will come and place here. I will use some other color to represent that. Okay, here the positive charge carriers will come and place here. Now you can observe that you are having a positive charge carrier here and a negative charge carriers here, separated by this thin oxide, to form the capacitance. What? To form the capacitance between whom? Absolutely, between the gate terminal and the channel. Is it clear? This capacitance I am going to call it as a parasitic capacitance. Is it understood, all of you? But don't forget, whenever you connected a potential between gate and source, is it understood? The formation of channel takes place. We know very well that when you apply VGS voltage, okay, after formation of channel, what is the remaining voltage? Absolutely, VGS minus VT. Similarly, here we are going to talk about that VGC, that means gate to channel capacitance minus the threshold voltage. Is it understood? Okay, we will see the remaining derivation step by step. If you are having any queries in the remaining derivation, you may please ask. Now you can observe what is the basic definition of current. Absolutely. Okay, charge upon time. Now what is the charge means? The charge induced in the channel, and the time here we have considered, that means electron transit time. From where the electron is going to be transit? Absolutely, from source to drain. Therefore the current is from drain to source. Is it okay? Now first of all we will see the derivation of electron transit time. We know that the concept of speed is equals to distance upon time. Based on that itself, time is equals to what? Distance upon speed. What is the distance for us? Absolutely, length of the channel, and the speed we are going to talk about, that is what? Velocity of the channel. Now very importantly, how the velocity will be takes place? Because of the movement of charge carriers and the electric field intensity between drain and source. Therefore this is mu n into EDS. This is mobility of electrons, and this is electric field intensity between drain and source. Now you can observe how this electric field intensity will takes place. Absolutely, this electric field intensity will takes place because of the voltage applied between drain and source with respect to what? Channel. Is it clear? Now if you observe that after substituting this VDS, okay, in this expression, what will happen? This becomes mu n into VDS upon L. Is it clear? Now after substituting this mu n into VDS, that means this velocity here in this place, then what happens? If you observe that L upon mu n into VDS upon L, then this L will go to the numerator side. Therefore finally what is the expression of that? Absolutely, what is the expression? L square by mu n into VDS. This is the electron transit time. Is it clear? Now you can observe that this is the electron transit time. That means L square upon mu n into VDS, length of the channel upon mobility of charge carriers multiplied with the voltage applied between drain and source. Is it understood? Now this very important derivation, electron transit time, is common for both the regions. Remember, it is common for active region, and it is common for which region? Saturation region. Absolutely. Is it understood, all of you? Okay. Now coming back to the important second part of derivation, that means we have to derive charge induced in the channel. Okay, in terms of gate capacitance we are going to derive. Okay, now you can observe that we know that charge induced in the channel is equals to the product of gate capacitance and voltage across that capacitance. We know that what is the voltage across that capacitance, since this capacitance is going to be formed after the formation of channel here, after the formation of channel. Is it understood, all of you? Therefore, what is the remaining voltage between this capacitance? You may tell absolutely. Okay, the voltage applied between the gate to channel minus the threshold voltage. Is it clear? That's why I have written the voltage across the capacitance is VGC minus VTN, and we know that what is VGC? Anybody? Absolutely. You can write VG minus VC. Is it clear? That means any potential, if you take any potential, if it is connected to gate, if it is connected to channel, okay, this is minus, this is plus. If you talk about what is that? Absolutely. Gate minus channel. Is it clear, all of you? Okay, therefore, this is the second step, second important point you have to remember. The first important point in the derivation is the voltage across the capacitance is VGC minus VT. And why? Because after the formation of channel we are talking about. Now we are going to derive this one. What is that? VGC is equals to VG minus VC. Is it understood? Now here if you observe that after this we have to talk about the voltage only in the channel. If you observe that if there is no gate voltage, okay, if there is no gate voltage, if we talk about what is the voltage only present in the channel now means, yeah, absolutely, okay, because of the other terminal voltage, that means source and drain, but here we are having two different voltages, therefore we are going to consider the average of them. That means Vs plus Vd upon 2. Here how I am changing this expression, I am adding the voltage, okay, across the source and subtracting that. Is there any change in my expression? Absolutely, I don't have any change in expression. Now this Vs plus Vs can be written as what? Absolutely 2Vs. Now you can observe that here Vd is there, here minus Vs is there. Okay, now if you observe that this Vd minus Vn can be written as what? Absolutely Vds. Don't forget the denominator 2 is as it is. Now if you further split this 2 gets cancelled. What is the remaining of this expression? Absolutely Vs, but don't forget the 2 is not cancelled for this Vds. Okay, this is Vs plus Vds by 2. Is it understood? Okay, now I'm going to substitute this Vc in VGC. Is it clear? Now if you observe that if I substitute this Vc here, then what will happen? Absolutely Vg minus Vs, it becomes minus Vds by 2. I hope that are you clear. Now you can observe that Vg minus Vs can be written as absolutely, what is that? Vgs minus Vds upon 2. Now if I further substitute here this, okay, VGC, is it understood? Now what will happen to my voltage across the capacitance? Absolutely, that means VGS, but don't forget I am returning this VTN before minus VDS by 2, therefore it becomes minus VTN. I hope that are you clear? Okay, minus what is that? VDS by 2. Is it understood? This is my voltage across the capacitance. Now I am going to substitute this voltage across the capacitance in Q. You know very well what is Q. Okay, Cg into V cap. Is it clear? Cg into V cap. Is it understood, all of you? Cg into V cap. Is it clear? Now if you observe that, what is Cg? Anybody from the class? What is Cg? Absolutely. Okay, Cg is equals to epsilon A divided by T. Is it clear? Now if you observe that, I am going to write Cg is equals to epsilon naught epsilon insulation. What is A? Length into width divided by D. I hope that are you clear. Now I am substituting this V cap and this Cg in this expression. What will happen? Anybody? Yeah, absolutely. We will see this. Now you may observe that Cg is epsilon naught epsilon insulation length into width divided by D. V cap is VGS minus VTN minus VDS by 2. Now we know that QC is equals to CG into V cap. Therefore, I am substituting this CG here and this V cap here. Therefore, I can get this QC. We know that what is the electron transit time? Absolutely. What is that? L square by mu n into VDS. Therefore, this one and this expression I am going to substitute in the major expression. What is that major expression? Ids is equals to QC upon tau st. Is it clear? Now we will see what will happen after substituting this. Now you may observe after substituting this QC and electron transit time, this L and this L gets cancelled. After that, how it is going to be looks like? Okay, absolutely. Is it clear? It is going to be looks like, yeah, it is going to be looks like in this fashion. That means Ids is equals to epsilon naught, epsilon insulation, mu n upon d multiplied with W by L ratio, VGS minus VTN into VDS minus VDS square by 2. Is it clear? This is a very important point you have to talk about. This is the derivation of Ids versus VDS. In which region? Absolutely. Okay. In active region. Which region? Absolutely active region. Okay. Now coming back to the saturation region, if you talk about, okay, we know very well what is the condition of saturation region, guys. Yeah, very good. The drain source voltage must be, okay, greater than or equals to the effective gate voltage. What is the effective gate voltage? VGS minus VTN is the effective gate voltage. That means if you substitute VGS minus VTN as VDS, now if you observe in this place, this is VDS. VDS into VDS what? VDS square minus what is the next term you are having? VDS square by 2. VDS square minus VDS square by 2 gives rise to what? Absolutely, VDS square by 2. That means this entire term is going to be changed as what? VDS square by 2. That's it. This is in saturation region derivation. Is it clear? Yeah, this is the relationship between Ids versus VDS. In which region, guys? Absolutely, in saturation region. Is it clear? Okay, now we will see some of the other forms of, okay, Ids versus VDS. Is it clear? I am going to talk about active region, then based on that you can just write down the saturation region. Is it okay? Now this is the basic expression we are having. Don't forget, I am not going to change this one for writing the other forms. This is same for all the other forms. Is it clear? Therefore, I am not going to waste the time. Therefore, this will remains as it is. Now, if you observe that, okay, if you assume that this as k, then what will happen? It becomes k into W by L and this expression will come. Is it clear? Now further, if you assume this k into W by L as beta, then it becomes what? Beta into this expression will come. Is it clear, all of you? This is the second form and this is the third form. Is it clear? Now once again, if you want to write the fourth one in terms of what? In terms of gate capacitance, you know very well what is gate capacitance. Epsilon naught, epsilon insulation, L into W divided by D. Now if you look about your basic expression, epsilon naught is there, epsilon insulation is there, divided by D is there. Epsilon naught is there, epsilon insulation is there, divided by D is there. You required in the numerator W, W is there, W is there. Okay, what is the remaining term you required here? L you required. But here what is the remaining term present? Mu n by L. If you required L, then what should you have to do? Absolutely, you should multiply and divide with that. Therefore, what will be this expression becomes? Absolutely, Cg into mu n upon L square, then it is once again going to be multiplied with this. Is it clear? And finally the last one, fifth one, that is in terms of gate capacitance per unit area. This is C naught x. Okay, in terms of gate capacitance per unit area, that means you should divide this gate capacitance with unit area. Okay, after dividing this gate capacitance with unit area, what will happen, guys? Just look once. Okay, you should divide with W into L. Okay, now you may observe that you require W into L here, but here what is that? L is there, therefore L square, one L will come and another L is going to be remains here. You require what? In denominator W, therefore this W will come. Therefore you can write this one as what? C naught x. That means mu n into W by L. That means that is mu n into W by L multiplied with what? The same expression. These are all the other forms of IDS. I will write very clearly. If you want, you may observe one more time. Is it clear? If you want, you may observe one more time. Now you may look all the other forms of IDS. This is in terms of permittivity, this is in terms of K, this is in terms of beta, this is in terms of gate capacitance. Okay, this is in terms of gate capacitance per unit area. Is it clear? Now these are all the forms of IDS versus VDS relationship. In which region, guys? Absolutely. In which region? Active region. Now what is the change in saturation region? Can anybody? Yeah, absolutely. What is the change? That means this part, that means this multiplication part. In this part, what you have to write? Absolutely, you have to write what? VDS square by 2. The remaining is similar. Is it understood, all of you? Okay, this about the derivation of IDS versus VDS. Okay, if you are having any doubt, you may ask. Finally, I am going to conclude this with a simple mass design equations. Okay, I am going to write for a 2 marks question. If this question asks what are the mass design equations, you have to write this one. Now you may look, if the question is given what are the mass design equations, you have to write this one. Whenever your gate to source voltage is less than the threshold voltage, there is any current? No, there is no current. Therefore the region is what? Cutoff region. If VGS is greater than threshold voltage and VDS is less than VGS minus VT, then the current is this one. Okay, I have written in terms of beta. If you want, you may write in any 5 forms of IDS. Is it clear? Therefore this region is known as what? Active region. Now you may look out the last one. What is that? If VGS is greater than VT but VDS is greater than or equals to VGS minus VT, then it becomes beta into VDS square by 2. Why? Because this VGS minus VT becomes VDS, then VDS becomes VDS square minus VDS square by 2 becomes VDS square by 2. What is that region? Saturation region. Is it clear? That's it for IDS versus VDS relationship. In the next class, we will see about the electrical properties of MOSFET, that is transconductance, output conductance and figure of merit. Is it clear? If you are having any doubts, okay, please comment. If you are having any queries, okay, please comment. Don't forget. Okay, thank you very much for each and everyone. Have a nice day.